Hello and welcome back to Friday Minis. Networks. As you can imagine, networks are ways in which you can have multiple devices, computers, phones, all connected together. Now, there are many interesting things to say about networks, from how the devices communicate with each other to how we physically connect them together. And today, we're going to focus on just one very small part of this picture. This part is what we call topology. Topology refers to, at least in a logical sense, how we connect devices together, right? Which devices are actually connected to which other devices. Depending on what topology you use, some interesting things can happen, namely collisions. When two computers decide to talk at the same time, what happens? How do we deal with it? So these are the two things we're going to look at, and we're going to see what interesting strategies are put in place for handling both of these. There are actually many topologies out there, but a few of them are more common than others, so I'll just talk about the most common ones. The first one is what we call a bus topology. This one is most useful when you have a large amount of computers to link together, because essentially what happens is there is a central backbone, and all the various devices just, tap into that backbone. What this essentially means is that all the devices are using one shared channel of communication, and this is when collision becomes, pretty destructive. As you can imagine, only one device can be using that central backbone at any point of time, and we have to be very careful to ensure that, all the different devices are actually sharing this resource well. So, what happens when two devices try to communicate? Obviously, they are going to, have a clash on the line. As it turns out, the easiest way to deal with this is, if you detect that a collision has happened, simply wait. Wait for some time before you retransmit again. Now, the interesting way in which this problem is dealt with is that the time in which you wait is a random amount of time. Obviously, it's not a huge amount of time, but it is random. This allows us to, with a fair amount of certainty, say that these two devices are not going to be able to clash again, right? And because of that, the two pieces of information can now be sent one after another. Moving on, another topology is what we call a ring topology. Again, there is a central shared resource here, right? Because again, all of these devices are sharing, essentially one backbone. In this topology, instead of allowing individual devices to transmit, as and when they want it to, we have what we call a token. This token is passed around from device to device, and essentially only when you have the token are you allowed to transmit. You're only allowed to use the resource when the token is passed to you. When you're done with it, or if you have nothing to do, you pass the token on to the next guy. So essentially, this prevents the problem from happening before it even happens. So yeah, because of that, you get a harmonious use of the shared resource because everyone takes turns. Moving on again, we have the star topology. Now, because the star topology is managed by some guy in the center, usually something like a network switch, what happens is there is technically no chance of collision between the individual devices. Thanks to the fact that they're not using a shared resource, they can technically transmit and receive whenever they want. The switch in the middle is the one that needs to buffer the packets that are coming in and decide where to push it off to. Because of this, collisions become less of a concern. But of course, for this to work, you will need a smart middleman. So yeah, there are pros and cons to each one of these topologies. So yeah, these are essentially a couple of topologies in a nutshell. This is a very fast oversimplification of each one of these topologies, but hopefully they show you something interesting. The very simple act of connecting multiple computers together requires so many different concerns to be thought of, and to address these concerns, there are so many different solutions, each with their pros and cons. That's all there is for this episode of Friday Minis. I hope you've gained some insight today, but until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.